Okay. So first thing for this is in this lecture it is logic gates. What logic gates? So what do you know about logic gates?
It's a gate of circuits,
Yes.
and it has many of the graphic symbol.
Yes. Okay. So basically, logic gates basically involves digital computerization. What is basically digital computerization means digital interpretation, binary signal, and impulse signal. So we deals with digital interpolation with two types of numbers. First is zero and second is one. So in logic circuits, the basic thing is my digital integrate interpretation, which is basically 0 1, and it is known as Boolean algebra. So it starts with my basic parameter, that is Boolean algebra. Give me 1 second. Boolean algebra. Okay, so Boolean basically contains two signals, whether it is 0 or it is 1. So 0 mean no, okay, 0 mean no, 1 mean yes.
Yeah.
Also 0 mean true, sorry, 0 mean false,
False.
and 1 mean true. Yes. This is about the digital interpretation, which is basically Boolean algebra and which contains two numbers, that is 0 and 1. Then the second parameter is my binary signal. What? Binary signal.
Binary signal.
Binary signal. Yes. So what is basically binary signal? Binary signal is a, let's suppose there is a value that is first it is 0, then 1, 1, 0, 1, 1, 0. So what does this mean? This means that I have multiple type of outputs. First output is 0, second is 1, third is again 1, then 0, then 1, 1 and 0 respectively. So let we divide this in seconds. So let's suppose that in 1 second my output is 0. In 2 seconds my output is 1. Ultimately 1, 3 second 1, and so on. So how to draw it? So we can draw it by using, okay, so what does the 1 mean? 1 means that my points will be, I have to change the marker. Yes, my points will be 1. This is basically the value 1.
So it rises at 1?
Yes.
At 1.
Yes. So it rises at 1, and at second node, let's suppose it started from 0. So it will be 0 from first pulse, second pulse. This is the first pulse. This interval from here to here, it is the first impulse. It is known as I described at 1 second. For 1 second, my input, my output is 0, so it will be shown like that. Then for the next second, it is 1, so it will be shown here. Then also 1, so it will be, I have to erase this, that my third signal is also 1. Just give me 1 second. Yes, my third, this is 1, and it ends here. Okay, so there is specific, now third interval is also 1, so it is also 1 from this. So it is 1 second here, then a 0. So 0 will, so this will show the 0 and so on. So this is the method and basically main parameters to describe our logic circuits. Just summarizing logic gates and logic circuits. So basically the logic gates are divided mainly into digital computers. So where there are digital computers, there are logic gates. Now in logic gates, there are two major things. First is digital interpretation. Digital interpretation means it is using Boolean algebra. So this is the digital interpretation, which is known as Boolean algebra, which contains 0 or 1. Now the second parameter is my binary signal. Binary signal is basically the graphical method to basically graph our output value. So these are the two major things to know about logic circuits or logic gates. Now the next thing is in logic gates, the binary number system is an alternate to decimal. So what does this mean, or how basically we are using? So it means that the binary number system. So binary number system, there are number system known as binary number. Binary number system. So what does this mean? Binary number means that we are using two numbers. Binary basically means two. So we are using two numbers, that is 0 and 1, which is basically the alternative of my decimal numbers. So by using binary number, I am eliminating decimal number from my logic gates. So it means that in computer, the inputs must be 0 or 1. There will be no other input signals to my logic gates. Is it clear?
Yeah, doctor. What
Yes.
do you mean by decimals? Like, what kind of decimal?
Okay. So decimal basically numbers like, let's see, it may be 1.123 4. Let's suppose my
But
data is
it
and
doesn't count the
yes,
after the decimal.
yes,
Okay.
0.23, something like that. So this is basically a discrete point. Discrete point means an absolute value. So absolute value is this one, 0 and 1. We will count only this 0 and 1 for my logic gates.
Okay, doctor. Now, if we compare between the Boolean algebra and the binary numbers, what can we conclude? Like, we know
Okay.
that Boolean algebra has 0 and 1, true or false. It's the same as the binary numbers.
Yes, definitely. It's the same.
So there is no difference?
Basically, binary number means, just to remember that, it is basically a number which contains 10 raised to power 0. Basically, it's a 10 raised to power n. So when it is 10 raised to power 0, what is the value? The value is what?
1.
1. Yes. When it 10 raised to power 1, so what will be the value? 10. So
10.
10 contains only 0 and 1. Is it clear? Then 10 raised
Uh,
to power 2, next number n. So it is 100. So in
yeah.
100, it contains 1, 0, 0. So it contains 0 and 1. So basically, Boolean is a smaller part. It is just like an atom. Okay, Boolean is an atom which contains only 0 and 1, and binary is a basically whole word which contains all the multiple parts, and it basically depends on number of values that you are computing.
Okay. Just give me a second, doctor, okay?
Okay, write it down.
Okay, sorry, doctor.
Okay. Now the next thing, next topic is, or next basically parameter is my logic block. Okay, logic block. So basically, in a gate logic blocks, there are two major parameters. First is my input signal, and second is my output signal. So a gate must have multiple inputs and only one output. Is it clear? So for logic circuit, I will draw
Yeah.
here. There is a gate. It may be AND or something else. There's a gate here. then there are multiple imports are adding into my gate. Let's suppose this is the first import, second or third and so on, multiple. Okay, and there is
Yeah.
on. Yes,
Is
yes.
it okay? Is it okay if we have more than one output?
More than, no, 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 only one output.
Only one output, huh?
Only one output. Yes, this is the main thing to remember. In logic gates,
Okay.
there is only one output. So there are multiple inputs, but the output is only one for my logic circuits. So for the demonstration or a schematic diagram, so you have to write here that it is my binary digital. So it is my what? Binary digital input signal. Input signal. So it will be my signal. So it may contains n numbers. It may contains my, depends on the n. N basically is the number of input and shows number of inputs.
Yeah.
Number of inputs in the system. And there is only one output. So only one output signal. Only one output signal, and this is also in my binary digital numbers. It also in my binary digital. So this is the basically it's the schematic diagram of my logic circuit or a logic gate. Whether it is AND gate, OR gate, NAND gate, NOR gate, and every gate, this is the basically the basic schematic diagram of my logic gate circuit.
Okay.
Okay, it doesn't depend that whether the gate is AND or, it totally depends on the number of inputs. So my, in designing, okay, the next thing is let's suppose you have a project in designing a logic circuit or a logic gate. I recently done a project on a gate, that is I am using multiple gate inputs, and I have done a impedance matching coefficient. So this is done by using by changing the number of input signals. So number of input signals are the most important parameter in my gates. So it basically my complexity of gate depends on the inputs. So we have to we have must have a close look on my input signals. So this is basically the logic block of my gate. So what about gates? So gates basically are the blocks of hardware that produce a binary output. So types of, let's suppose we are dealing with the types of logic blocks. So for this, is it clear about the structure of logic gates?
Yeah, the output should be, it will be a signal, like it will be
Yes, output.
rising and like you
Yes,
explained
yes,
before.
yes. 0, 1. Yes, it whether be 0
Yeah.
or 1. So it will be like
Signals?
yes, signals. Yes, signals.
Okay,
It is
okay.
also known as impulse. Okay,
Impulse.
impulse.
Okay.
Impulse means that whether it is 0 and 1. So this is
Uh,
all about my logic block schematic diagram. Let's move towards the types of basic logic blocks. So there are two types of logic blocks. So let's move forward towards the types of logic blocks. So move towards types of logic blocks. Types of logic block. So there are two types of logic blocks. So first logic block is known as combinational and second is known as sequential.
Sequential, yeah.
Yes. So first it is known as my combinational logic block. Combinational logic block.
Which I think it depends on the inputs.
Yes, I will describe it. So combinational logic blocks basically whose output logic value depends only on the input logic value. Again, combinational logic blocks are the types of logic blocks whose output value depends only on input logic values. So just I have to write it. Just give me 1 second.
Yeah, no problem.
Combinational logic blocks. So combinational logic blocks depends on basically, and there is uh, combinational logic block whose output logic values whose output logic values output output logic values output logic value depends only on depends only on what? On input logic values. This is the major thing to remember.
Doctor, you can refer back to these slides if you want to save time.
Okay. Just give me okay. On import logic values. Just give me 1 second. Values. Okay. This is all about just I will write the main things and inshallah, and after this you have to I don't write these all type of definition. Is it okay?
Yeah, no problem. Because it's already in these slides there, Doctor, if you don't want to.
Yes. Then the second is my sequential logic blocks. Sequential logic blocks. So sequential logic blocks are what? Logic. Yes. Define
depends on the input logic block state value.
Okay. What is basically state? Yes. What is the state basically sequential? So in sequential, basically it depends on two parameters. First is my input value and the state of the block. So what is basically state means? So state means, let's suppose this is my gate. There are multiple inputs, 1, 2, and 3. Okay. So there is an output depends on what? Output depends on my input values and then the state of the block. So let's suppose the state of block is positive. Okay, is positive. Positive means what? Positive means OR. Let's suppose it is OR. OR is a positive gate. Okay, let's suppose the inverse of OR is NOR. Okay, so it will be negative in this case. So it in sequential logic, it depends on input, also the state in which my gate is or my block is. So combinational only depends on input, but the sequential logic depends on my input and also on my state in which my system is. The example, you can quote the example is, in case of OR, we use, this is my positive sequential logic, but in case when it is, we are using the invert of OR, that is my NOR, so it will be negative sequential logic. Is it clear?
Yes, clear.
Okay. Now moving towards my combinational gates, which is the most important thing to remember. So what about AND, OR, and XOR, NAND, NOR, and
Yeah.
yes, these are the gates basically used every day, and the major thing in these gates are my truth table. So you must need to, let's suppose there is a,
I know them already, doctor. This is
yes,
like I went through them. Like I
okay,
took a course before it. It's named like Discrete Structure.
okay,
Some
let's,
of it's
yes,
familiar
okay,
to me.
let's suppose there are two system added in my system. Yes, can you solve this type of system?
Yeah.
And there's a multiple input and it is connected to, let's suppose it is connected to my uh, NOT gate.
Yeah, inverter.
Yes, so this is basically depends on my operations. So this is AND gate using multiplication, OR gate using what, plus.
Addition.
Yes. So moving towards, so as you say that these are the things which are easier. So moving towards the next, that is my Boolean algebra. So Boolean algebra also that I described earlier, it is basically the variables or the values that is my input and output system contains. It may be 0 or 1, yes or no, and true or false. So these uh, are the symbols which basically represents that my input or output signal is what is in Boolean algebra. Again, my Boolean algebra
Yeah.
depends on two parameters, 0 and 1. Okay,
Okay.
so now the next thing is my truth tables. So truth tables are basically the combination of tables. Combination basically depends on the operation. Let's suppose in case of AND, we use A plus B or A minus B, A multiply B. In case of AND, so I am using word, in case of AND, it is A multiplied by B. So the table of A multiplied by B is known as my truth table. So this is the about my truth table. Now moving towards the next topic, that is my basic identities of Boolean algebras. Have you remember all these and or not?
Yeah. All
Okay,
of them.
okay. Now about what about equivalent circuits?
I've heard about them too.
Okay,
Equivalent. Yeah.
okay. Uh,
It's like referring back to the identity.
yes.
Some of the identities, it's like the associative identity.
Multiplicative identity, distributive
Yeah, some of
identity.
these. Yeah,
Yes,
exactly. This
yes,
table,
yes, yes,
like yeah.
yes. Now, the next thing is my complement of functions. So, have you know about complement of functions?
Yeah, it's like negating them or yeah.
Yes,
Become
yes. Inversion. Uh, I will. It is basically 26 minutes. Okay, we will go fastly. That inshallah we will cover the
yeah.
maximum things in this lecture. So, what about simplification? Simplification. You know about simplification?
Yeah, it's like also depending on the identity. It's like
Yes.
minimizing the Boolean algebra. Boolean
Yes.
functions, I mean. Yeah,
Yes. Okay. Okay. Then about mapping. You know about mapping?
it's the K map, right? The kernel map.
Yes. Yes. It is about
Yeah.
multiplication of different parameters. Okay. I think you know many things about.
But
Yes.
I
Yes.
have problem with mapping, like if there was like 4 inputs in the table, and I think maybe yeah, it's about the surrounding them, making circles,
Okay.
having like inter maxter.
Okay. 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 So we will do this. Basically, this is my mapping system of what? Mapping system basically for an undefined inputs. Undefined inputs means that there are n different types of inputs, and we are using what? Sum of products. This is known as sum of products.
Sum of products.
So sum of products mean basically we have to basically sum it and then product it in the form of Boolean algebra. So in case of, let's suppose there's a rectangle divided into two n cells. So what does this means, and what is basically the mapping, and how things basically change from one point to another point. Okay, so please give me 1 minute for water. So I will continue
Yeah,
after
of
1 minute.
course, of course. No
Okay.
problem.
Okay, let's start about mapping. So mapping basically depends on my truth table. Okay, so let's suppose there are multiple inputs and outputs in the system. So how to define all these? So basically we have to multiply. Let's suppose there are two tables in case of four tables. So let's suppose there are the tables of ABC, and the output must be shown in what? In zero. So it will be like, just give me 1 second.
Doctor, I just want to know how to, minimize it and without consuming more time
Okay,
during the
okay,
exam.
okay,
So
okay.
some tricks, ways.
Yes, 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 yes. I got. I understand. Yes, there is a. Let's suppose there are four tables, just like that. Yes. Just give me 1 minute to do it. Okay. So there are. Let's suppose there is A, B, C, and F. First, let's suppose 0, 0, 0. So what does the 0, 0, 0? How to find the output for this system?
The output for the system,
Yes.
it depends on the input.
Yes, it is 0 0 0. Abdullah,
It
it
will
is
be
0
zero
0 0. Yes. Why 0?
because by adding them, combining them, we get zero. Is that
Okay.
right?
Yes, you are right. Now, second is let's put 0 0 1. What are you?
One.
Why 1?
Because after combining them, there is still one of them, and then the
Okay.
result will be one. Is that right? I'm not sure.
Okay. So first thing to remember is 0 0 1. It is basically combining both
Oh, okay.
both parameters. So 0 and 0 will be what? 0 plus
Zero.
0 0, and then we have to multiply. So 0 multiplied by 1.
Zero.
Yes, so the output is 0.
Oh, why did we first multiply and then we add?
This is basically, I said that it is sum to product system. This is the basically function of this system as I described
Oh,
earlier.
sum of products.
Yes, 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 yes. Just give me 1 second. I will turn to your slide. This is your slide number mentioned in your slide number uh, 15. It is basically sum of products. So for sum of products mean first you have to do the sum, then the product, and then so on. Is it clear?
Clear, clear, yes.
Okay. So it will be, let's suppose it will be, table will be given to you. Is it clear? So this is all about the performing of table. So first thing for table is, where is my mouse? Yes, this will show that there are two paths. The first path is a b a b a b, and then this part shows c, that this cross section is basically of 0 0 ab, and this cross section is of c. So let's say that it is a b, which is what? 0 0. It may be 0 0. It may be
Yeah.
0 0 1. It may be
One, one,
1 1. It may be
one, zero.
1 0. Yes. For c, it may be 0
Zero, one.
or 1. Yes. So what about table? What is table
Show the
showing?
table.
Yes.
It's a truth table.
Yes. It depends on truth table. Okay. So
Mm,
first thing is, what is 0 0 0? What is the answer of 0 0 0?
zero.
0. So we have to add here. Where is my mouse? Sorry. Here again, I am elaborating that first 0 0 means this is 0 0,
Yes.
and then it is 0. So 0 0 0. So 0 0 0 means here it is 0. Is it clear?
Yeah.
Now second
Yeah.
is 0 0. So 0 0 is where? This is 0 0 AB, and what is the value of C is 1. So 0 0 1 is basically 0. So we have to plot here 0. Is it clear?
Yes.
Let's suppose you have given a truth table. It totally, now the truth table basically is given to you. You have to make this map. So let's suppose for just mapping, I have to complete this table. Okay. So inshallah, you will be able to do any type of question relative to in the exam. So let's suppose
Inshallah.
it is 0 1 0. Let's suppose it is 1. Depend, now it totally depends on my logic circuits and logic gates. Okay, my truth table depends on my three parameters a b c, what the input values are. So whether there is not gate, inverted gate, positive gate, or something else. So now 0 1 1. Just give me 1 second to 0 0 0 0 1.
But
Oh no.
doctor, it's different in the slides.
Yes.
It is different on the slides. What is in the slides?
Slides, just give me 1 minute. I have to check it. Just give me 1 second. Just I have to uh, Okay, I showed that. Just minute. Just give me 1 minute to complete this table. 1 1 1. Then 0 0 1 1. So lastly it is 0 1 0 1. Okay, again, uh, I don't know what the operations are performed in the slides, but uh, this truth table is given to you always. Okay, you have to tabulize this in your mapping. So it totally depends. This A B C is what? It is my input types A B C. Now A B C must be connected to some gates. So the gate may be not gate, nor gate, and gate, XOR gate. Okay, so my truth table, you only given a map, just like this diagram, a diagram like that in the exam. Let's say it is A B, one input here, then it is combined, and there is a this. So you have to make a table, truth table for this system. Let's say it is A, B, and C, and F is for my output.
So we're
So
saying that the output will be already given. It's not
yes,
from me.
no. It depends on the teacher, but the thing which is given to you in the paper is this circuit diagram, which contains basically A B C D, this type. uh, this may be depends, this circuit diagram. Then after this circuit diagram, you have to make a truth table. Okay, then after truth table, you have to make your map. So this is a complete process. So uh, 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 you say that you know about the truth table, how to make a truth table. So I skip this portion, so I go to the mapping. So any question regarding this truth table, how to make this truth table?
Uh,
Abdullah?
well, doctor, I'm not. Yeah,
Yes,
doctor,
yes.
I'm not sure if it's constant numbers of the F, because maybe sometimes it's different or it's always like this.
Sometimes it
The
different.
answer, I mean.
It different. It depends on logic
Difference.
gates.
Yeah,
I
okay,
say that it
right.
depends on logic gates.
Okay, okay.
Don't be confused on the truth table. Truth table may be different. Okay?
Okay, now, okay, we need to simplify it now.
Yes, yes,
The
yes.
simplification.
The
Yeah.
main thing is you have to compute this table on your mapping. How to map
Mhm.
this table. Yes?
So I need to
So
follow the steps. First of all, I need to watch the what should I call this? I forgot. The
uh,
diagram.
yes, this is basically schematic diagram of your gates. After
Yeah.
this gate, Abdullah, listen. First,
Mhm.
there in a question, let's suppose in a paper, you only given a schematic diagram like this, a gate diagram. After this, you have to solve it. Solve it by using what? By using truth table. This is the
Truth
truth table.
table.
This is the truth table. After this, after the making of truth table, you have to make a map. Is it clear?
Okay. Yes, clear, clear.
Okay, okay. Let's move towards my next thing is what? Uh,
Simplification.
yes, 0 1 0 1 0. So what is the value of 0 1 0? This is 0
Zero.
1 0. It is 1.
Oh,
Again,
it's one. It's already there, yani.
yes, A, B. Now, third is 0 1 and 1. So 0, this is my fourth, this part. So 0 1 1 will be what? 0.
Zero. But doctor,
Yes,
you said that it's a sum of products. So we first add and then we multiply it, right?
yes, yes. But basically, it depends on this is this. Mm, for example, this I am taking just a example
An
for you.
example.
Yes,
Okay.
example that it depends on this. It totally depends on my circuit diagram. Is it clear?
Okay.
My
Yes,
truth
clear.
table depend. This is just for the elaboration that how you basically put the values in your map.
Yeah. Okay.
So
Okay. Let's go for the simplification part, please, Doctor.
yes, is it clear
Yeah.
about the
Clear now.
mapping? About the mapping?
Yes.
Yes. Okay. So now the basically map simplification. So how to basically simplify two adjacent cells or more than two adjacent cells. So let's start with two adjacent cells. This is the major topic to understand. Okay. So let's say I have a block circuit like that, 2 cross 2. It may be 0. Let's say it is 0 1 0 0, again a 0 1 and 1 1, and there is a partition of y and x parameters. So what is basically map simplification? So in a binary, basically when representing my binary circuits, so we have to basically associate with adjacent cells. So what does this means? Cells, basically I am referring uh, some parts from one cell to another. It is basically the method to represent different types of cells for my output signal. Let's say I have to find the summation of summation of what summation of two variables, that is my x and y. So summation of this depends on what. Now after start before start I have to add some rule, that there's a rule that x
Hello.
and y invert plus xy equals to, now I am taking x as a common, so here it is x y plus y invert, that is my y negative. So this y positive and y negative will cancel with each
It will be
other,
one.
so it will be x, yes, it will be 1, and then the answer will be x. 1
Yeah.
multiplied by x multiplied 1 equals to this one. So what to do? It basically depends on, first I have to multiply what? I have to multiply with x, this parameter x with x invert. So x means
Doctor, I know
1.
these steps, but the thing here is that we need to simplify it without doing these steps, because these steps will take time. It's like
uh,
drawing a circle
yes,
on a
yes,
whole in the table.
yes. Okay, so
It's
yes, yes,
collecting
yes,
the much bigger
much
number
bigger image. Okay,
column.
this,
Yeah.
yes, 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 for two cross two adjacent cells, this is the simplest formula to define. When there is more
Yeah.
than, so we have to use a basically corner method. Corner method is basically I am using my corner cells to identify the value of the submissions. Let's say we have a 4 cross 4 matrix or 4 cross 4 circuit. So it will be 4 cross 4. So for 4 cross 4, I will define some values. So these values are my basically simplification method. So first thing is for 3 cross 3, again for sorry, for 4x4 system, having four adjacent cells in each side. So let's suppose this cell value, this cell value, this cell value, and this cell value. So these cell values, these cell values are basically represented as U invert and V invert. What is basically U and V invert? I will describe it later. Then for second, the trick is this one, this, this, and this. This is a cube. This is basically a square. So square basically defined what? Square basically defined the product of V and the invert of W. And the later part, this is this part, let's put this part, and this whole square will show what? This will show the U and W. This will be same. The formula must be, so for simplification, I have to sum it this value, then this and this value. So this value basically means what? Let's say, I have an example.
Yeah, our doctor, he uses a step that says what? It says that those who changed, we remove it or something like that in
Uh,
terms of bar.
okay, just give me 1 second to elaborate. Just give me.
Okay.
Let's say it is 1 1 0 1. So this is basically what? 1 1 0 1. So it is basically the things related to my u invert and v invert. So this u invert and v invert is what? 1 1 1 0 1. Now, this is basically what? This is a decimal number. So we have to convert a binary number or hexadecimal number to find a typical value. Let's say this value equals to, my number equals to 50. Okay, we have to convert this numbers to what other systems. Let's say the second number is 1 1 0 1. So my location will be, I will read this and then
Doctor,
this.
there is no time. There is no time. There is still 10 minutes. Can we leave this part, Doctor? We can go for the don't care part
Okay, okay.
or flip
Next,
flops.
flip flops. Flip flop.
Because,
Yes.
yeah, we need,
Uh,
can
due
we
to
go to
time.
flip
Okay, okay,
flops?
okay, okay, okay. So
Because, Doctor, the drawing take many time, more
yes,
time
yes, yes, yes.
than
I know
expected.
it. I know it. So flip flops.
Yeah.
So basically flip flops, clock flip flops.
Just the
So
definition of a flip flops and what it's about, like that, you see.
yes, okay. So flip flop basically how it works. It works on basically the invert function. This is just like when I multiply two input values and then invert its output. So it is same as my flip flop. Let's say my value is 1, output value is 1, so I will flip flop it to 0 value. This is used in the system where,
Invert.
yes, where there is basically uh, 0 output values are more than 1 output value. So I 0 means my circuit is doing no work. So in case when there is 0, so my system is lag, in position lag. So my system must be in position 1 for the efficiency and for the working. So flip flop are the major parts which converts my 0 signal to 1 signal. So basically this is the industrial use of my flip flops. Then using towards my flip flop basically there are two conditions of my flip flops. First upper condition is known as my latched condition, and second is my positive conditions. So there are two major things to remember in my flip flops. So the next basically the typical flip flop used in your slide is clocked flip flop. In clocked flip flop, this is basically there is a AND gate and NOT gate, sorry, AND and OR gate, and this is connected to one NOT gate, and they are connected randomly. So this will make a flip flop circuit with a clocked value. Clocked value basically is a value which shows basically three parameters. First parameter is known as S, second parameter is known as R, third parameter is known as C. C basically is my middle point. S is basically is my first positive terminal point, and R is my negative terminal point. So for S and R condition, when it is between S and R, it is known as SR flip flop. When it is above C, so it is C flip flop. When it is below C, it is known as R flip flop. So again, in my clocked flip flop, there are three basic terminals. First upper part is known as C. Sorry, upper part is S, middle is C, and last one is R. If my clock signal is at C, so this flip flop is known as SR flip flop. When my clock signal is above C, it is known as S, only S flip flop, and when it is below C, it is known as R flip flop. So there are some also uh, there are some other conditions known as toggle condition. Toggle condition is a condition when there is when in my flip flop there is the input values are one. So again, when my all input values are one, my flip flop is considered to be in condition known as toggle. So we have to, because flip flop is used for inversion of output. So in case of 1 1, it will be 1. So this condition is known as toggle. So for flip flop, we will remove this value and we will change with this value to latch. Latch will basically is a value which basically use a negative input. Negative input means the output must be zero and it will invert this output 0 to 1. But in toggle condition again, output is 1 and it will invert. After inversion it will be 0. So this is the about toggle flip flop. So toggle flip flop is basically frequently used in the counters. Counters basically, there are counters just like counting 1 2 3 impulse rate. So toggle flip flop are my sequential flip flop which does not skip any value. So toggle flip flops are the most common used flip flops. So it has two inputs. So first input is my T input and second is my clock input for toggle. So T, again, for toggle inputs, toggle flip flop, there are two inputs. First is taken as T input and second is my clock input. So when let's suppose when T is 1, when T is 1, my flip flop changes its state, and when T is 0, no change occurs. Again, this is the last basically thing in my parameter added in my slide number 1 is toggle flip flop. There is this flip flop is used commercially in the industry. Secondly, it is used for the counting. Counting means for a use as a counter of let's say in a clock, in a stopwatch, and all these things. So for internal structure, it has two inputs. First is a T input and second is my clock input. So my all the output values depend on T input. Okay, T input. When the T is 1, so basically the flip flop changes its condition that flip flop is working properly, and it is showing some graphs when T equals to 0. So it means that my flip flop doesn't change any parameter and no change take place in my output value. Abdullah, any question about flip flops?
So the toggle flip flop is depending on the toggle if it was one or not. But the thing is that the Q plus means that Q XOR T.
Yes, yes, yes. Again, toggle flip-flop, Abdullah, basically depends on two inputs. First is T input, and second is what? Second is my clock input. Okay, so
Okay, okay.
when T is one, there are two parameters. T whether T is one or zero. So when T is zero, so flip-flop changes its state, and when T is zero, there will be no change in my system. So there is a q positive. So there's a formula to find q positive. So you can find q positive equals to what? It is equals to,
XOR T.
yes. So it depends on the uh, summation of two parameters. So this is all about my flip flop. Then again, there is a latched and flip flops are basically uh, use as my internal state flip-flops. Internal state flip-flops means, Abdullah, that it is just like a system. Uh, let's suppose I am programming in C++, and there is a number of loops n. N means number of loops, so it will take iteration. That let's suppose my iteration will run from 0 to 7. So n will define that how many steps will be performed. So in step determination, there is a flip flop. So the flip flop basically used uh, in the what, in demonstration of my internal signal. It is known as toggle flip flop, which is used in the internally. And also latch flip flop is also used internally in the systems. uh, I think there is first slide is covered. Any question regarding first slide?
Which slide?
Slide number one, Abdullah.
Number one?
Yes.
Oh, no, doctor, it's fine, I think. But doctor, the thing is that the thing that wastes time is the drawing, you see. But in explanation, you are so good, doctor. In explanation.
Yes, yes, Abdullah,
Yeah, we can just consider
yes,
the slides and we just continue and switching slide to slide, you see, and just
yes,
read
yes.
and explain more about what's inside the slides.
Okay,
It's
okay,
better
okay.
than drawing and doing
Yes,
yeah,
yes, yes, yes. Basically, drawing. Some students want to basically draw the internal structures and some things. Okay, so if you want tomorrow's lecture, book tomorrow's lecture. Inshallah, we will start from chapter number two and from slides. Inshallah. So it will cover,
inshallah, I'll see you, doctor.
inshallah cover chapter slide number two and three. Inshallah. So any question
Inshallah.
regarding this? This is basically chapter number one is the basic. There is, I don't think there is a difficulty regarding this slide. So in case any difficulty, you can question it in the next session, Abdullah. So
Yeah. I'll try, doctor, because maybe there is a probability that maybe I will drop this course due to some like it because I'm loaded with many courses, other courses. You see, other important courses. Because I'll see it, doctor.
okay, 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 okay.
Yeah,
Basically, it's a course which is uh, um, you are a student of bachelor's. You are doing BS.
yeah, yeah, bachelor, doctor.
Okay, okay, okay. So, which semester?
This is the second semester.
Oh, yes,
So I'll
second
try,
semester.
doctor, because yeah, I'll try to do my best because doctor, this because I'm loaded already with many courses,
Okay,
and
okay, okay.
maybe I'll drop one of these. Maybe this is one of the courses that I will drop, and maybe I'll take it next semester or
Yes.
something like that.
Yes. This
Yeah,
must be at the end. This must be at
yeah.
fifth or seventh something, because this is the
Ah,
complex electronics and
yeah. It seems
complex
so,
logic
doctor.
circuits. Yes, yes, yes.
Yeah, I'll see,
Okay,
inshallah.
okay. Don't worry. So, okay then. Goodbye
Thank
from
you so
here
much,
and
Dr. Muhammad. Thank you
okay,
for your time. Really appreciate your helping me, doctor. Thank you.
okay.
Have a
Thank
nice
you.
day. Thank you.